We now discuss a problem on probability, and this question has appeared in the joint entrance examination main held on 20th July 2021 in the afternoon shift. The problem is based on the addition theorem of probability. The problem is, let A, B, and C be three events such that the probability that exactly one of A and B occurs is 1 minus k. The probability that exactly one of B and C occurs is 1 minus 2k. The probability that exactly one of C and A occurs is 1 minus k. And the probability of all the events A, B, and C occur simultaneously is k square, where 0 less than k less than 1. Then the probability that at least one of the events A, B, and C occur is, the four options are given. The first option says exactly equal to 1 by half. As the second option, greater than 1 by 4 but less than 1 by 2. Third option, greater than 1 by 8 but less than 1 by 4. The fourth option, greater than 1 by 2. We recall the addition theorem of probability. The probability that at least one of the three events A, B, and C occur is given by probability of A union B union C is equal to probability of A plus probability of B plus probability of C minus probability of A intersection B minus probability of B intersection C minus probability of C intersection A plus probability of A intersection B intersection C. And this may be seen through the Venn diagram in the adjoining figure. Agreed. Let us discuss its solution. Solution. The probability that exactly one of A and B occurs is given by probability of A minus B union B minus A. Probability of A occurs but not B union B occurs but not A. So, probability of A minus B union probability of B minus A. Let's see the Venn diagram. So, now probability of A minus B union B minus A, these are mutually exclusive. That means their intersection is empty. Then therefore probability of A minus B union B minus A will be probability of A minus B plus probability of B minus A. This happens because they are mutually exclusive events. And if you want probability of A minus B, it is A but not B. That is, from A and B you remove. Then it will be A but not B. So probability of A minus B is probability of A minus probability of A intersection B. Probability of B minus A will be probability of B minus probability of B intersection A, which is same as probability of A intersection B. So this is that will be equal to probability of A plus probability of B minus 2 times probability of A intersection B. The probability that occurs exactly one of A and B occurs is probability of A plus probability of B minus 2 times probability of A intersection B. Given the probability that exactly one of A and B occurs is 1 minus k. 1 minus k. So therefore probability of A plus probability of B minus 2 times probability of A intersection B is 1 minus k. In a similar fashion, probability that occurs one of B and C that occurs that one of B and C occurs is 1 minus 2k will be probability of B plus probability of C minus 2 times probability of B intersection C is equal to 1 minus 2k. And similarly, the third one, the probability that exactly one of C and A occurs will be probability of A plus probability of C minus the probability 2 times probability of A intersection C, that is 1 minus k. So so we bring forward this is the first equation, and the second equation, the third equation. Now what we do is and given the probability of A, B and C occur simultaneously is k square. Simultaneous means A occurs, B occurs and C occurs. That is probability of A intersection B intersection C is equal to k square. Now we add equations 1, 2, 3. Then we will get probability of A plus probability of A 2 times probability of A, 2 times probability of B, 2 times probability of C minus 2 times probability of A intersection B minus 2 times probability of B intersection C minus 2 times probability of C intersection A. 2 is common. Take out 2 common. Probability of A plus probability of B plus probability of C minus probability of A intersection B minus probability of B intersection C minus probability of C intersection A is equal to sum of 1 minus k, 1 minus 2k, 1 minus k. So you add them, you will get 3 minus 4k. And send this to the other side, and you will get probability of A plus probability of B plus probability of C minus probability of A intersection B minus probability of B intersection C minus probability of C intersection A will be 3 minus 4k by 2. And the probability that at least one of A, B and C occur is given by addition theorem of probability, and probability of A union B is equal A union B union C is equal to probability of A plus probability of B minus probability of C minus probability of A intersection B minus probability of B intersection C minus probability of C intersection A plus probability of A intersection B intersection C. So probability for the first up to probability of A intersection B intersection C is 3 minus 4k by 2, and the probability of all the three is given by k square. So that is equal to 3 minus 4k by 2 plus k square. So take the LCM, 2k square minus 4k plus 3 whole by 2, and that is equal to 2 times k minus 1 whole square plus 1, and divide by 2, it will be equal to 1 by 2 plus k minus 1 whole square. So therefore 1 by 2 plus k minus 1 whole square will be certainly be greater than 1 by 2. So the probability that at least one of A, B and C occur is greater than 1 by 2. Options are our answer greater than 1 by 2 appears against the option 4. The answer is option 4. So that is the discussion of the solution of the problem on probability, which uses the addition theorem of probability. I hope that you have understood the problem and its solution, and I wish you all the best. Thank you.